Good morning. We are going to study the relation between energy and force. This is energy and force. What is the relation between energy and force? Energy, it is the ability to do work. It is the ability to do work. And work is a kind of energy. What is meant by energy? Energy, it is the ability to do work. What is meant by energy? It is the ability to do work. When work is done, energy transferred, lost or gained. Energy may be lost or gained. Energy and work are measured in joule. This is the unit for measuring of energy or work done. Joule equal Newton dot meter. Joule is the unit for measuring of energy or the unit for measuring of work done is joule or Newton dot meter. Work is done when force moves a body through a distance. If you have a body, this body is moved through a distance. Work must be done. Work is done when a force moves a body through a distance. This means that work equal force times distance in a certain direction. Distance in a certain direction is called distance moved. Is called distance moved. Work is done against the friction due to the surface. This surface makes force in the opposite direction is called frictional or friction. Work is done against gravity. Due to the weight of the body, there is a gravity. Work is done against gravity. This means that work equal frictional force times distance moved, or work is done equal weight lifted and height moved. Height moved. If this body has weight and this body is moved in this direction, height, this is the height moved, a distance covered in a certain direction vertically. Example, for this girl to climb the stairs, she must do work. This girl must do work against gravity, and friction must do work against gravity and friction. Work against gravity equal weight of her body times height. Work against friction equal friction with stairs and length. Length, this is the length. This is the length. Now we study power. Power is the rate of doing work. Power equal work done per unit time. It is the work done per unit time, or it is the rate of doing work. If a power is the rate of doing work, or the rate at which the energy is transferred, because work done equal energy. This is called energy per unit time. Energy per unit time. Power is the energy transferred in time taken, or work done divided time taken to calculate the power. The power increases when more work has to be done. More work has to be done due to an increase in the force exerted, or the gravitational potential energy, or the kinetic energy. More work has to be done due to, number one, increase in the force. Number two, due to increase in the potential energy. Number three, due to the increase in the potential in the kinetic energy. Number three, time taken decreases because the relation between the power and the work directly proportional, and the power and the time is inversely proportional. This means that time taken decreases. Time taken decreases. Example, the more powerful machine is, the quicker it does a fixed amount of work. Please know that work has nothing to do with speed or time. If work is 1,000 joules, it doesn't matter whether you spend this energy in 10 seconds or 10 days. On the contrary, or power is how fast this amount of energy is spent against or gained, spent or gained. This is the power. Now we are going to study the efficiency. Efficiency. What is meant by efficiency? Each engine is operated when supplied by energy for a certain source, for a certain force. Example, food is the energy source to the human body. Fossil fuel is the energy source in the power station. A machine converted one form of energy to another useful form of energy. The process of energy conversion is not 100% efficient. Because part of energy is input, is converted into another useless, wasted form of energy. Part of input energy is converted into another useless, wasted form of energy, which usually appears as heat and sound. For example, wasted energy. The input energy useful energy plus wasted energy. The input energy equal useful output energy plus wasted energy. This is example. 100 food for human body. 75 wasted heat and energy, and the kinetic energy 25%. This is the useful energy 25%, while the other part wasted energy in the form of heat. Another example, in the power station, 100% fossil fuel The wasted heat energy 70%, while the useful energy 30%. 30% from 100%. In this state, 25% from 100% fuel, food of the body. Another point, now we study the principle of conservation of energy. The principle of conservation of energy. It states that the total energy of system remains constant. The total energy of a system remains constant. According to law of conservation of energy, energy cannot be created or destroyed. This is called law of conservation of energy. Principle of conservation of energy, of law conservation of energy. Energy neither created nor destroyed, but it can only convert it from one form to another. Law of conservation of energy mean that energy neither created nor destroyed, but it changes from one form to another. Example, kinetic energy. What is meant by kinetic energy? It is the energy of the body due to its motion. Kinetic energy, type of energy, is called the kinetic energy. It is the energy of the body due to its motion. Any moving body has kinetic energy. During friction between two objects in contact, kinetic energy is converted to heat energy. Kinetic energy converted into heat energy. Kinetic energy of braking cars is transformed to heat energy in the brakes of the car. This is a kind of energy, is called kinetic energy. Another kind of energy is called gravitational potential energy. Gravitational potential energy, it is the energy which is gained by the body or stored inside the body due to its position. On the earth, gravity acts as gravitational potential energy. GPE, gravitational potential energy. When we are above the earth's surface, we have stored gravitational potential energy. This is a sphere in the surface of the earth. It moves up, has potential energy, and this potential energy, and this potential energy. During motion, kinetic energy and potential energy. All potential energy at the site, it moves. All potential energy, no kinetic energy. At this position, at height h from the surface, it has gravitational potential energy, but it does not move, so no kinetic energy. When it moves in this position, it has kinetic energy and potential energy. When it reaches to the surface of the earth, the height equals 0 because h equals 0 between the sphere and the surface of the earth. Potential energy equal mgh. The height equals 0. This means that potential energy equals 0 and all energy only kinetic energy. When it moves up at a certain height, it contains kinetic energy and potential energy. When it reaches to this position, it has all energy is potential energy, while kinetic energy equals 0 because it does not move. Another example for it. If you have a simple pendulum, this is a simple pendulum. At this position, the height equals 0. maximum kinetic energy and minimum potential energy equals 0. And at this point, all energy is potential energy, kinetic energy equals 0. At this point, like the last point, all potential energy, no kinetic energy. If the body bounce back to less height, it moves from point and can go up. At this point, all energy is 0 except kinetic energy is maximum. And the lost energy converted into heat energy and sound energy is lost energy, wasted energy during impacts. When it go up, the kinetic energy increases while the potential energy increases while the kinetic decreases until it reaches to this point. At this point, has maximum potential energy and the kinetic energy equal 0. Goodbye and good luck, my students.